All right, pre-algebra students, we are moving on to the final part of our slope lessons. This is where I'm introducing slope formula. We should be able to determine the slope of a line using slope formula, or the slope of the line between 2 points. So I will introduce the slope formula and why it's needed, and we will practice finding slope in tables, graphs, and between 2 points. Make sure that you are following along with your guided notes, and let's get started. So let's investigate slope for a second here. So to find the slope of a graph, Aiden counted the rise to be 6 and the run to be 8 and set up the ratio 6 over 8 equals 3 over 4. So it looks like he used a triangle setup here. He identified 2 points on this line and said, I can count the height of this triangle to be 6 units, and I can count the base of this triangle to be 8 units, 6 over 8. So that means the slope of this line would be 3/4. Using the ordered pair shown though, he could have found the rise to be 6 a different way. You'll notice that the y value of this upper coordinate is 16 and the lower coordinate is 10. So he could have subtracted the y values. Subtract the y values, and to do that, it would just be 16 minus 10, which is 6. And he could have found the run to be 8 by looking at the x values. I see 16 and 8. So we'll subtract the x values. All we're doing is still finding the change in y and the change in x. To determine the change, we can subtract the values. So when we subtract the x values, that would be 16 minus 8, which is 8. So we're still calculating rise over run, just in a more precise way. And here's where the slope formula comes in for us. We know that slope can be described as the following ratios: rise over run, or change in y over change in x. We've also seen it this way: delta y over delta x. Just means change in y over change in x. And because of these ratios, we can use a specific formula for slope. If we have 2 coordinates, the first one would be x1, y1. That's coordinate 1. And we have coordinate 2 at x2, y2. And all these variables represent are just any 2 points on a line, any 2 coordinates on the line. We can create this formula for slope. Slope is y2 minus y1. All I'm doing is subtracting the y values from each other, divided by x2 minus x1. This formula is extremely important to knowing how to find slope of a line. Sometimes you're only given 2 points on a line, and you need to use this formula to give a precise answer. So let's try this out. And remember our slope formula again? Slope is m. M equals y2 minus y1 over x2 minus x1. So let's try this out by finding slope in tables and graphs. And again, the whole method is the same. We have to identify 2 points in a table or a graph and find the slope of the line, or the rate of change between them. So in problem 1, when we're given a table of values, I've got x values on top, y values on bottom. All of these are just coordinates. 0, 5 is a coordinate. 1, 5.5 is a coordinate, and so on. Remember, we list x values, then y values when we write coordinates. So all I have to do is choose two of these four coordinates to find slope. I'm going to take the easy way out here. I'm going to use 0, 5 and 2, 6. So when I write my formula, my slope formula, I'm going to subtract my y values first. So I'm going to go 5 minus 6. 5 minus 6. And then divided by my x values. So if I subtract in this order, 5 minus 6, or my left coordinate minus my right coordinate, I need to subtract in the same way on the bottom of my fraction. So instead of it being 2 minus 0, I need to subtract 0 minus 2. The same order must apply. And so my slope, after I simplify this here, 5 minus 6 is negative 1. 0 minus 2 is negative 2. So fully simplified, my slope of this line would be 1/2, or my rate of change would be 1/2. For every 1 x increases, y increases by 2. Okay, so when I find slope on a graph, I need to identify 2 points that are on the line. So the first coordinate I see is at 0, 80. 0, 80 is on the line. My second point that's identified here is at 5, 50. So notice I have two y values, two x values. So I'm going to put them in slope formula. Slope formula says I subtract my y values on top first. So I'll go 80 minus 50. This coordinate's y value minus this coordinate's y value. And then I'm subtracting my x values in the same way. So if I subtracted 80 minus 50, I need to subtract 0 minus 5. So now I need to simplify. 80 minus 50 is 30. 0 minus 5 is negative 5. So my slope, if I divide top by bottom, my slope is negative 6. So as y decreases by 6 on the graph, x increases by 1. Down 6, right 1, down 6, right 1 on this graph. For additional practice with problems like this, try out problems 2, 10, and 11. Let's just try out if we're given two coordinates. So on problem 4, a graph line passes through these 2 points, 2, 4, and 1, 7. We're going to find the slope from the ordered pairs. So let's start with slope formula, and then I'll plot the points and show you the line. So remember I have x, y, and x, y. So I just need to remember, slope formula says y2 minus y1 over x2 minus x1 equals slope. So let's plug this in. I'm going to subtract 4 minus 7. And I'll subtract my x's in the same order. That would be 2 minus 1. And when I simplify, 4 minus 7 is negative 3. 2 minus 1 is 1. So my slope is negative 3 over 1, or just negative 3. Here's what my line looks like plotted. So if I plot the points 2, 4, here's 2, 4 on the graph, and 1, 7. So if I draw a line through those points, it's not the best line in the world, but you get the idea. Okay, so if I had a ruler, this would be a much more fancy line. And I'll go and erase that. I can do that better. I can do that better. All this line really says is that as y decreases by 3, x increases by 1. So down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1, and you get the idea there. So this line has a slope of -3. Now let me try this one, problem 9. I'm given the coordinates 7.53 and 7.52. So I'm going to plug these into my slope formula, subtract my y values first. I'll do 2 minus 3, my right coordinate minus my left coordinate. Y values on top, your rise, and your run would be your x values subtracted from each other. 7.5 minus 7.5. Now let's simplify. 2 minus 3 is a -1, and 7.5 minus 7.5 is 0. And from our previous lessons, we know that we can't divide by 0. So this slope is undefined. And we know that all lines that have an undefined slope are vertical lines. Let's prove that by plotting these points. So we have the coordinate 7.5, 3. So we've got 3, 6, 7.5, 3. Here's 7.5, 3, halfway between 7 and 8. And we have 7.5, 2. So there are those 2 points. Notice how they're on the same x value. That means that if I draw a line passing through them as neatly as I can, here is my line. Notice how I've got a vertical line here. All vertical lines have an undefined slope, and we proved that using slope formula. Pretty neat stuff. For additional problems like this to practice, try out 5 through 8. I've got one more application of slope here. This time we've got a word problem. So it says the post office charges a flat rate plus a cost for shipping based on the weight of an item. To ship a 2-pound item, it costs $6.09. I think that's some pretty important information there. To ship a 7-pound item, it costs $8.84. Similar information, just different numbers, right? So we're asked to find the rate of change, and we all know that rate of change is just another way of saying find the slope. I see that I'm working with 2 different types of numbers here. I notice that I'm working with weight in pounds, and I'm working with money or cost. So I think that my rate of change is probably going to be cost per pound. In other words, cost is my y value, and weight is my x value. So I'm seeing 2 coordinates here. My first one, a 2-pound item, costs $6.09 to ship, would look something like this. 2 pounds, $6.09. My second coordinate would be 7 pounds, $8.84. And we know by now that we can find the slope or rate of change of this relationship between cost and weight. So let's plug it into slope formula. Slope is equal to my y value subtracted from each other. Let's do 884 minus 609 divided by my x value subtracted from each other. That would be in the same order, 7 minus 2. And when I simplify here, let me double check. I can see that 884 minus 609 would be 275, and 7 minus 2 is 5. And if I divide that, I'm going to get a rate of change or a slope of 55 cents per 1 pound. So obviously there are some additional charges in this shipping company, but the rate of change is 55 cents per pound. So that is our lesson on slope formula. Thank you again for watching. Make sure that you try out the additional practice problems and check your answers with mine. And as always, ask for support in Math Help Desk if you need it. Have a lovely day.